What's up, guys? It's time to hop into some math lesson today. We are going to look at and use stuff we did in the last section, the last video actually, with the proportions and solving proportions in this section of indirect measurement. So indirect measurement allows you to use properties of similar shapes to find distances or lengths that are hard to measure directly. For instance, if I want to measure something really tall, it's going to be difficult to do, but what we can do is use a similar figure. So for instance, if I measure the height of this person and I can see the length of their shadow, and I can measure the length of the shadow of this basketball hoop, then I can kind of find the height of the basketball hoop using the fact that these would end up being similar triangles. In shadow problems, we can assume that the angles formed by the sun's rays with two objects at the same location are congruent. So these two angles on the ground, we can assume are congruent. If the objects are the same general location, then that angle formed by those sun rays will be the same, which would make, since we have a right triangle, two sets of congruent angles, then we could say that those are similar. So we're going to use this indirect measurement to find measures of things like that. So we're just hopping right along here, and let's look at this. The lead scout statue of the Korean War Memorial casts a shadow, so we can measure the length of this shadow. This nearby tourist that's 64 inches long casts a 32-inch shadow. So how tall is the statue? Well, again, we'll assume these angles are congruent because they're in the same location, so the angle of the sun will be the same. And these are both right angles, so these are both congruent, two pairs of congruent angles, so these triangles are similar. So if they are similar, then we can set a proportion to solve for the missing height. The tourist height is 64 inches, and the tourist shadow is 32 inches. We don't know the statue's height, but we know the statue's shadow. So notice that the tourist is both the top, their height, and the shadow, and then the statue is both the numbers on bottom. So it is important where you place these values here, okay? But then the way we did this yesterday, and I'm going to do this a little different because I think this way works a little bit better, we're going to cross multiply. So 32h equals 64 times 43 times 5. I think it's a little easier than, especially when the values aren't exact, it's a little easier to solve it this way than having to figure out, so having to figure out like what you have to multiply by. Why? This is 2784. Okay, let's make this a little bit better. 2784 is what that equals. 278. Oh my goodness. 8. Stupid thing. Now I'm just making it worse. Now it just hates me. Okay, 2784. And then we would divide both sides by 32 to give us h equals, really, 87. Oh my goodness, you guys. 87 is the correct answer here. 87. We'll do it this way since it doesn't want to recognize a touch screen right now. So the height of the statue is 87 inches. Okay, let's try this again with another problem. So in this case, we are told the triangle DBA, this triangle right here, is similar to ECA. Now, there are cases where you're going to have similar triangles where kind of one is part of the other, so that's okay. So this small triangle is similar to this whole triangle, but part of the triangle is part of this big triangle as well. So for this small triangle, angle A is angle A for this big triangle as well. So A is congruent to A, and these two are congruent, so these triangles are similar. So we are given a few different things, and we want to find the distance across the lake. So we have all these measurements here. We want this distance across the lake. So we're going to set up a proportion for these here. What happened there? Interesting. Oh, so we can separate these. Oh, look at that. Oh, okay. So we can separate this and put it down here. We'll put this in the box here, and that way it's a little bit easier to see what proportion we would set up. Okay, so now if we want to find this missing side here, we could say that, let's see how they did it here. I'll keep it the same, so it's the same as in your book. AB over AC So this side over this whole side equals BD over CE. So long side, hypotenuse on top, or excuse me, this leg on top over this leg right here. So AB is 320, and this whole side would be 320 plus 162. So that would be 482. And then this side is 40, and then D is our unknown. Okay, so just kind of to write it over here so it's a little bit easier to see, possibly for you, if this will work. 320 over, what did we say that was? 482. So again, this side over this side equals 40 over D. This side over this side. So all we're doing is setting up a proportion, and then the easy way to solve this is to cross multiply. Instead of trying to figure out what we have to divide or multiply by, 320D equals 482 times 40, which is 19,280. And now this is a very simple equation to solve. We just divide both sides by 320, and we get the D, the distance across the lake, is 60.25 meters. Okay, so we're setting up proportions and plugging in the values in the correct spot. Okay, both the numbers on top go with this triangle, both the numbers on bottom go with this triangle, and then cross multiplying to solve for the missing value. So you guys try the two check problems on example 1 and example 2. Do the check problems, and I will be checking for those to make sure you have those to give you credit for this assignment. And that's all we've got for the notes. So have a hoppin' good night.